Hi everybody, good to see you all again. So, we're going to start off with a somewhat strange problem here, but it seems to work out pretty well. So, we're told that S is false and Q is true, and what's the truth value of this statement here? So, one thing we could do, just like what we've done before, when we have a statement like this, we can create a truth table. So, it's very possible for us to generate a truth table for this entire thing. Now, it seems like a bit of a waste, especially since we only care about a very specific case here, and in particular, we were told that S is false and Q is true here. So, in a way, I mentioned that this Boolean logic is very akin to that of algebra and arithmetic here. So, this is similar to saying, what's the value of 3x squared y squared minus, x squared y when x is 4 and y is 3. You don't need to go through all the steps for this here. You don't need to go through every single value, because they told you what x and y were. In much the same way, they told you what s and q are here. So we might as well go ahead and substitute those things in. So we know that s is false and q is true. So as a result, we can start substituting things in. So for instance, since s is false, I can start plugging that in here. So we can substitute this in. We know q is true. So I'm just going to, just like we would in an algebra class, substitute in all the values that we have. And then we can worry about the operators. Okay, so notice that again, we swapped all the s's for false and q's for true because we were told that that's the case here. So now the first thing we can do is we can start working on the negations, right? Just like with any other thing here, we can deal with the negative signs first. Let's deal with the negations. So we know that negations flips the value of the truth of the statement. So we know that this is therefore false or false. Implies false and true. If and only if. Not false is true. And not true is false. So right now, again, we've taken care of the negations, and it's gotten a little bit better, I suppose. Okay, so let's continue. We have false or false. We know that a disjunction, again, is false when both pieces are false. We have false and true here. That's a conjunction. Both pieces need to be true, but they're not. Here we have true or true, which is true. And we have a false here. So now this is broken down into something a lot more manageable. I think you can see that this is much, much easier to deal with. So now we have false or false. False implies false, which is a true statement here. Again, it's vacuous. True implies false is false. Now, if you remember here, we talked about the biconditional. The biconditional is only true when the true values match, and they don't match here. So we know that at the end, this entire thing is going to be false. So this statement here should be false. Okay? So we see this sort of thing here. All right. So I'd like to get started here with this. All right? So, we've dealt with a lot of statements here. In particular, we've looked at conditionals. And you're going to note that I'm going to do a lot of conditionals here. The reason I'm going to do a lot of conditionals is because they form the backbone of many of the statements that we're going to be looking at in geometry here. So, I want to focus on a very straightforward conditional. If it rains, then the ground is wet. Right? And I think we can agree that this is going to be a true object. Let's say that this is a true statement here. If it rains, then the ground is going to be wet. Fair enough. Now, note that in this situation here, one thing we can do is that we can write this in a slightly different way, right? We can say that, so this is our good old P implies Q here. So one thing that we can do is we can start messing around with this. We can create related conditionals by simply messing around with the antecedent and the consequent here. So one of the simplest things that we can do to mess around with something is switch their order. So we can change things up so that we can make the we can swap the order of the antecedent and consequent and make Q implies P. So instead, it will be something along the lines of if the ground is wet, then it rains. And this we refer to as known as the converse. So with our original statement, P implies Q, our converse is now Q implies P. Okay? So it switches the order of the antecedent and the consequent here. And as you can see, we get something a little bit different. The converse is that our thing here. Okay? Of course, it doesn't have to be just a swapping of these. It would go back to the beginning, right? And instead of swapping the order of these things here, we can negate them. So we can say not P implies not Q. In this case, that would be something along the lines of if it doesn't rain, then the ground is not wet. That we refer to as what is known as the inverse. So the inverse, we can negate the hypothesis and conclusion, or in this case, antecedent and consequent here. If it does not rain, the ground is not wet here. So we see that we have not P implies not Q. right? So we can see that that's also something that we can consider as well. The antecedent, we have this. So our inverse looks like this here based on our original, okay? Now, again, we have that. We also, if you consider this here, we've swapped the order of the antecedent and consequent. We've negated both of them. So, why not do both, right? It's kind of like this sort of thing here. If you have a pigeon and a rat, you can just put them together and create a pigeon rat, Now you're thinking like a simic here. So, in this case here, we can do both converse and inverse at the same time, both swap the antecedent and consequent and negate them both, and we end up with something that's known as a contrapositive. So in this case, the contrapositive here is the result, we're both negating and swapping the hypothesis and conclusion here. So in this case, it'd be something like, if the ground is not wet, then it does not rain. Okay? So we seem to have this sort of thing here. So we have, for any given conditional here, we can take a look and see that there are 3 related conditionals that we're going to be looking at here. So this is sort of our converse. So again, we can just run through it again. The converse, which is where you swap the 2 objects. The inverse, where you negate both objects. And the contrapositive is when you do them both. And these all can be generated from any given conditional here.